All right, well, this is like the third time now that you've seen this little title here. Man, got a little cough going on. Oh, what's going on? Well, forgot to plug in my little graphics tablet. That would help. There we go. Yeah, now it works. Good. Does that work? Yep. All right, we ready? Feels like a Monday, doesn't it? Man, I was here early and everything. I was going to get here early, get everything all set up. And then I was doing some stuff. And then I forgot to print out the, whatever you call it, the lesson plans and then the worksheet. And anyway, you don't care. Let's keep going. Do you remember the little, I called it a mnemonic device to remember sine, cosine, tangent? Sohcahtoa. How do you spell Sohcahtoa, even though it's not a real word? S-O-H, so, and then what? C-A-H for ka, and then the toa, that's an easy one, T-O-A. What, you don't like saying it like that? Go ahead, pull it down. Pull it down. Come on, I'm busy teaching here. Guys, you want everything, don't you? I tell you. Yeah. There's a lot of things I got to do to set up for this class, isn't there? That's all right. You don't have to go all the way down because it only goes to there anyway. So, all right, we good? All right. So let's go through this very briefly. We've already talked about this once, and just thought we'd do this quickly before we get into some real examples. So if you can remember this little thing right here, Sohcahtoa, you should be able to remember your trig functions. So what is the SO? S-O-H. Why do we remember that? It's the sine is equal to the opposite over the hypotenuse. It's supposed to be an H, okay? Sine equals opposite over hypotenuse. That's why we learn this, okay? Please memorize sine or Sohcahtoa. If you can remember Sohcahtoa, you can remember these trig functions, okay? It's not that difficult to remember them. Today, we haven't really learned up to this point why we use this stuff or what the purpose is, but we're going to today, hopefully. So what is the cos? C-A-H. C is the cosine. The A is, what is that word? It's adjacent, so it's that over H, which is the hypotenuse. And then the TOA, T is tangent, equals, and we've already used both of these, that's the opposite over the adjacent. Okay? And we did that with a right triangle. Let me grab that right triangle. Where is it? Way down here. Come on. Get it. Where is it? There it is. Copy. And then let's go over here. Again, this is just review. So there's a nice right triangle. Why will it not grab that? There it goes. I'm sure it's me. All right, and so let's call this theta right there. Theta, again, is the angle that a lot of mathematicians use. It's kind of like our convention for missing angles. You can use other letters of the Greek alphabet or the English alphabet if you wanted to, and we will. We'll call this triangle ABC. We might call this angle A instead of angle theta, all right? And a lot of times they'll do that. But in general, excuse me, we call a missing angle theta. So let's put some stuff in here. Let's do this. Let's say that's 3. Let's say that's 4. What's this going to be? Anybody remember from geometry? If one side is 3, it's a right triangle. If one of the lengths of the legs, I should say, one of the legs is 3, the other is 4. Does anybody remember? It's 5. That's right. Okay. It's Pythagorean Theorem. Let's do this Pythagorean Theorem in our head. What's this? Pythagorean Theorem. 3 squared is 9 plus 4 squared is 16. 9 plus 16 is? Take the square root is 5. All right, it's one of our special triangles. Remember that from geometry? Okay, it's been a couple years, right? But hopefully you remember that. So what if I ask you to find the sine of the angle? This is not officially an example yet, but we're getting to it, all right? What if I ask you to find the sine of this angle? Remember, the sine is not a variable. You don't solve for the sine. The sine means it's just a word that represents a certain ratio. And what ratio does it represent? It represents the opposite side divided by the hypotenuse. Do you remember that from the other day? All right, so don't get confused. Don't think the word sine is like a variable. It's not. Okay, theta is a variable. It's an unknown thing, in this case, an angle. So just remember that. The sine of an angle means just what are you dividing? You're dividing the opposite side divided by the hypotenuse. So on this angle right here, theta, this particular angle, which side is the opposite side of angle theta? Is it the 3, 4, or 5? What's opposite of theta? What is it? It's 4. That's right, because it's opposite. It's across from it. Remember that? If you have trouble understanding this, make sure that you ask. I see some people not taking notes. You should be taking notes on this. This is the time where you should be taking notes. So the opposite is 4 over the hypotenuse. The hypotenuse is always opposite the right angle. So this will always be the hypotenuse. I'm not saying 5 is always the hypotenuse to every single right triangle, but in this case, the 5 is the hypotenuse. Okay, so that's the sine of the angle. And you're probably thinking, well, who cares what the ratio is between, the sides of the right triangle? Well, we will in a minute, okay? In a minute or two, we're going to learn how to use this stuff practically to find stuff, all right? Let's keep going. Let's do the cosine of the angle. So the cosine is the adjacent over the hypotenuse. So this angle theta, which one is adjacent to this angle? Which one is next to, that's what adjacent means, which one is next to angle theta? 3, okay? And that's over what? It's adjacent over hypotenuse. Which one is the hypotenuse? It's 5 again. So the cosine of the angle, the ratio of two sides of our triangle that represents the cosine, is 3 over 5. Let's do the tangent. The tangent of the angle is the opposite over the adjacent. Okay, we've already figured out which one's the opposite, which one's the adjacent. Now you just put them together. The opposite is what? 4, and the adjacent is 3, and that's how you set it up. Okay, we really haven't solved for anything yet. Okay, we haven't solved for anything. We will in a few minutes. Thank you. Did she just keep it? Okay. So we will in a minute, but you got to know this stuff first. Okay, you got to know how to set up sine, cosine, and tangent before you do anything else. This is the key. If you're lost here, you're going to be lost the rest of the chapter, I promise you. So get it straight now, all right? If you have any questions, ask me. Ask your fellow students, okay? After this class is over, go to a study hall and say, what world was Mr. Hamrick talking about today? Of course, most of you have my study hall today, right? So come and ask me. If you have any questions, come to me at 2:30 during the study period and ask me. I'm available, and people aren't using me as a resource, okay? Only in class time. So come to me for extra help. That's how we set this stuff up. Now, if we wanted to, I don't know if they do this in the worksheet or not, but let's do this. Let's do the inverse functions. Okay, the inverse functions. Do you remember what the inverse? If you have your notes, if you took notes from when we did this on Friday, you should know this. What's the inverse of the sine? There's a word. It's the cosecant. Remember, it's the other letter. Remember we got cosecant and secant? Now, you know cotangent and tangent would go together, right? Because they got that word tangent in there, right? It's the cosecant and the secant are the ones that people get mixed up. So the cosecant is the inverse of the sine. How can you remember that? Because the sine starts with an S, the cosecant starts with a C. They're inverses. They're different, okay? So the sine and the cosecant are the ones that are inverses of each other. Well, if it's an inverse, how can we find that? If the sine is 4 over 5, what do you think the cosecant is? 5 over 4, that's right. Okay, and again, later on, we're building foundations, all we're doing today. Well, at least in this part right here. What's the inverse of the cosine? What was the other word? I said it once today. It's the secant, and we just put SEC. And it's the inverse of the, sorry, I keep coughing. It's the inverse of the cosine. So basically, what do you do with the cosine? You take the cosine one and you just flip it. And so what is that? That is 5 over 3. All right, so it's not that bad. Man, if I can get that frog out of my throat. It's not that bad to find the inverse of these. You just flip the fraction. Okay, what's the inverse of the tangent? That's the easy one to remember anyway. It's the cotangent. Look at over the tangent. The tangent was 4 over 3, so guess what the cotangent is? It's 3 over 4. That's how you find your inverse functions. I don't sit there and memorize that the cosecant is hypotenuse over opposite. I don't memorize that. I don't have a little device like this to remember my inverse functions. All I do is memorize my basic trig functions, which is really not that hard if you can remember Sohcahtoa. If you can remember that, you can find your inverse functions, because all you do is you take the one that you know, and then you just flip it, and that's how you find the inverse functions. I don't think in this section right here we're going to do a whole lot with the inverse ones, but later on we will. All right, so just make sure we know that. All right, well, let's actually do an example. How about that? Yay. This was kind of example 1, tell you the truth. So we kind of did an example already. So this, I didn't even look. But anyway, that's example 1. All right, but we haven't really solved for anything. We haven't found anything. That's what I like to do, don't you? Solve for x, find missing stuff. That's what I like about doing math. So example 2. Here's what it says. Write it down. It says if the cosine of A equals 2/5, find the value of the tangent of A. Find the value of tangent of A. Now, we're actually not even solving for anything here. Again, there is just a warm-up. It's just to get you to figure out what's going on. You're like, okay, well, what in the world's going on here? The cosine of A is 2/5. They don't tell you what A is. They just tell you what the cosine of A is. They tell you the fraction, the ratio, okay, of angle A is 2/5. Well, it's cosine, so we know the 2 must be the what? Is it opposite, adjacent, hypotenuse? What is it? Cosine is adjacent over hypotenuse. The 2 must be the adjacent. The 5 must be the what? The hypotenuse. So what I'm going to do is I'm going to, I'll tell you what. I think I already copied. Yep, I already copied the triangle. And I don't really care if it's to scale, to tell you the truth. If you wanted to draw it to scale, that would be perfectly fine. Oops, oh my goodness, look at that crazy thing. I think I got to click off of that before I start drawing. There we go. That was weird. All right, so let's call this angle A. We're not calling it theta this time. We're going to call it angle A. And I just put it on the outside instead of inside like this. Now, this is always the hypotenuse, isn't it? So if you take a look at this, remember what the 2 was? 2 was the adjacent, and 5 was the what? Hypotenuse, because it's the cosine of the angle is 2/5. So I can fill a couple things in here, can't I? So what do I put right here? Put a 5, because that's the hypotenuse. Now, this is the angle that I'm dealing with. Which side is adjacent? Is it this one on the bottom or this one going up and down? The one on the bottom right here. Okay, that's the adjacent side. So what's the length of this? Now, again, I did not make this to scale, did I? All right, because look at the 5 and look at the 2. The 2 should be a lot shorter, shouldn't it? But it's not to scale. We don't care. I just got a right triangle. It's all I need. What are they asking to find? They're asking to find the tangent of angle A. What is the tangent of angle A? Well, what is it as far as opposite, adjacent, hypotenuse, and all that stuff? What's the tangent? It's TOA. So it's opposite over adjacent. Okay? I know the adjacent, which is what? 2. I know the adjacent of angle A, that's 2. What do I put here? It's this one right here, isn't it? I don't know that one. So I could find it though, couldn't I? Let's call it little a. Is that all right? Because it's across from big angle A. But I could find it. How could I find it? We've done it once today. We kind of did it in our head. But what are we going to do? This isn't quite as easy to do in our head. Pythagorean Theorem, exactly right. Okay? So I want to find this missing side right here because I need to put it right here. I need to find what that is. So I could just do Pythagorean Theorem. This is something that we did in geometry. We did it in the review chapter at the beginning of this year. So let's do it now. It's a squared plus 2 squared. Remember, it's the 2 legs squared and added up equals the hypotenuse squared, or c squared, which is 5 squared. Remember this? Now let's do some math. So it's a squared plus 4 equals 25. Subtract a 4 from both sides. I'm showing you every little step. Some of you guys should be able to do a lot of this in your head, and that would be fine if you did. A squared equals, what's that? 21. Now I got to solve for A. How do I solve for A? It's A squared, so what do I do to get rid of that squared? Square root it, that's right. So if I square root it, I just get an A. If I square root this, I get a what? Square root of 21. Does it simplify? Nah, because 3 times 7, I can't break down 3 and 7, so that's my answer. I'm not even going to write it as a decimal. Not right now anyway. Eventually we will, okay, but not right now. So what is A? It's the square root of 21. So what's the tangent of A? It's the opposite over the adjacent. Remember we had that missing spot right here? So now what are we going to put up here? Square root of 21. What is the tangent of A? It's the square root of 21 over 2. That's how we write the answer. What do you think? That's not too bad, is it? And you're probably thinking, Mr. Henry, you really still didn't even find anything. Well, yeah, we found a missing side, but we already knew how to do that. What is this trig stuff good for? Why in the world do we need to know this trig stuff? Well, I'm glad you asked, because we're going to do it right now. Okay, we're going to do an example right now, and I'm going to show you where we actually use this trig stuff. I'm tired of the white. Let's go to, I don't use green too much, do I? Let's try this lighter green. All right, so this is example 3. And they give you a triangle. And, can I flip this? Transform. I thought there was an easy way to flip this. Is it one of these? Is it this? Ah, there we go. Flip horizontal. Yeah, that's what I wanted to do. I knew it was in there somewhere. I'm just trying to make it look like the one in my notes. So it kind of looks like this. All right, grab it. There we go. So let's fill it in. So they give you a triangle. It's a right triangle. Remember, these trig functions can only be used with right triangles. So that's what this whole section is about right triangles. They actually tell you what one of the angles is. It's 30 degrees. And they give you that as 8, and they give you this as x. And they want you to find x. This is where all the stuff that we've learned up to this point, this is where it culminates in solving for a missing side, or sometimes solving for a missing angle, which we'll do in a few minutes, okay? So this is what we're going to try to do. Can I use Pythagorean Theorem to solve for x? We did it to solve for one of the other missing sides. Why can't we do it here? Somebody tell me. Not because of the angle. Why can we not use Pythagorean Theorem? Billy, why can't we use Pythagorean Theorem here? That's right. You only got one side, okay? For Pythagorean Theorem, it's a squared plus b squared equals c squared. You got to have to know at least 2 sides, right, to find the third side. So we can't use Pythagorean Theorem, but we do know something else. We do know an angle, and we know one of the sides. If that's all you know, you should be able to find all the missing parts of this triangle. Right now, they only ask you to find one, but sometimes they'll say solve the triangle. What does that? What in the world does that mean, to solve the triangle? It just means to find all the missing parts to it. What are the other missing parts? Well, you got x right here. This is missing, right? We'll call that y. What else is missing? The other angle. We'll call that b. All right, this one right here. You with me? Without doing any trig at all, how do you think you could find angle b? Can you find angle b right away? What do you think, Josiah? Very good. He's got it. Okay, all 3 angles, remember this from geometry? All 3 angles add up to 180 degrees. You probably remember that from elementary school. I think they teach you that stuff, okay? But they all add up to 180 degrees, and so you know this is 90, you know this is 30, so how do we find this? Just add these 2 up and subtract from 180. Or, you know what's even easier when you have a right triangle? You're going to go 180 minus 90 every single time anyway, aren't you? So really, what can you do very simply right here? Just one little math thing. Well, what's the math though? 90 minus 30, that's right. Okay, so to find angle B, it's just what? It's just 90 minus 30, which is what? 60 degrees. So angle B is 60 degrees. They don't even ask you that on this example. I just put that in there for fun, just so you can figure that out. Okay, they will ask you that in a little bit, but that's just a little warm up. All right. Now, again, we can't solve for y, we can't solve for x by Pythagorean theorem, but we can do it with trig functions. Let's do x first. Okay, then we'll do y. Even though they don't ask for y in this example, we'll still do it just for some extra practice. So what in the world are we going to do? Well, we know we're going to use this angle, right? And we're going to use one of those trig functions. We're going to either use like sine, cosine, or tangent. So that means we need to know either adjacent, opposite, or hypotenuse. Which one are we solving for, and which one do we actually know? Well, we actually know this one. So what is this one? That's the hypotenuse. What's this one? To angle 30, not to 60, but to angle 30, what is this side? This is adjacent. Let me ask you this. What is this side relative or compared to angle 60 in reference to angle 60? If I have angle 60, is this still adjacent to angle 60? No, what is it? It's opposite angle 60, isn't it? So it really matters what angle you're talking about. So right now, I'm using angle 30. So this side right here is adjacent to angle 30, but it's opposite of angle 60. You with me on that? What about the y? Y is what to angle 30? Opposite angle 30, but it is what to 60? Adjacent to 60, okay? Keep that in mind. I might have gone all off track a little bit right there. I didn't, but you'll have to know that later on. But anyway, let's just deal with 30. Forget the 60 right now. This is adjacent. This is hypotenuse. Now, which trig function? I'll write this here. This should be in your head, all right there. I used to tell my classes, you should walk down the hallway. When you see each other, you should say Sohcahtoa to each other, all right? That's your like secret language greeting for each other, all right? When you see each other in the hallway. So I want to hear that. When you see me in the hallway, yo, Mr. Hamrick, Sohcahtoa, like Josiah, Sohcahtoa, all right? And then we got that connection, right? I know, I'm a big dork, but that's okay. I'm proud of it. So which one are we going to use? We got adjacent, we got hypotenuse. Which one of these are we going to use? Are we going to use sine? That's opposite and hypotenuse. Do I know the opposite? Nope. Can I use tangent? That's opposite over adjacent. Can I use that? Nope. What about cosine? Yes, adjacent and hypotenuse. So what I do is I look to see what I'm trying to solve for, and I look to see what I know. I'm trying to solve for x, and I know the 8. I'm looking for adjacent, and I know the hypotenuse. So that means I'm going to use the cosine. So how do I set it up? I take the cosine of the angle. What angle am I using right now? The 30 degrees, right? That's the angle that I'm talking about, the 30 degrees. So I take the cosine of 30 degrees. Remember what the cosine is. It's just a ratio between two sides, between the adjacent and the hypotenuse. What is the adjacent side? It's x. What is the hypotenuse? That's 8. Now I have it set up to actually solve for x. Now all I have to do is some basic algebra. You see what I did there? Okay, I saw what side I'm asking for. I saw the side that they tell me. I'm using this angle. This is adjacent. This is hypotenuse. Which one of these has adjacent and hypotenuse in it? This one right here, the cosine. So I use the cosine of the angle, right? Got to put that angle right there. The cosine of the angle equals the adjacent over the hypotenuse. Now I can solve for x. So what do you think? What am I going to do to solve for x here? Said I was going to use green, didn't I? And I used it just to write that thing. Why am I not? Uh-oh. What happened? Crap. Okay, there we go. Sometimes I touch stuff and I don't know what I'm doing. All right. So I want to get x by itself, don't I? How do I get x by itself? What is going on with the x? What's happening to the x? That 8 is doing what to it? Dividing. How do I get rid of something that's being divided? Multiply. Do the opposite, right? So I come over here. I multiply this side by 8. And what do over here? Multiply that side by 8. Now this cosine of 30, it looks kind of weird, but it just represents a number. All right? It's just a number. It's a decimal number. You can use your calculator. This is where everybody's going to need a calculator. You don't need a graphing calculator. You just need a little scientific calculator. If you go to Walmart or you go to a drugstore or something like that, you could probably get a scientific calculator for like 10 or 12 bucks, something like that, okay? So that's all you need, but you do need one. I am not going to let you use your phone. Everybody understand that? All right. Now, I have it written down here, but I'm just going to explain it to you. I used to have a calculator that I could put on the screen, and now that was on my old computer, and I've looked and looked and looked online, and I don't really have a nice calculator that looks like your calculator to put on here anymore. And I got to still keep looking for it. But anyway, I could use that. What was that one? Desmos? Yeah, I could use that if I wanted to, but I'm not going to right now. Kylie, did you have a question?
Oh, am I allowed to my car to get my allergy medicine?
Are you what?
Can I go to my car to get my allergy medicine?
Are you sneezing?
My nose is
No? Well, get a tissue or something. You need to watch this. Okay, so watch. This cancels out. So what do we get? We get 8 times the cosine of 30. So you're not going to write your answer like that. What are you going to do with this? You're going to put it into what? Your calculator. How in the world do we do that? Well, good question. Here's what I would do. If you have just a regular, if you have a graphing calculator, who actually has a graphing calculator? I see one right here. If you have a graphing calculator, you can put it in just the way it looks right here. You just put 8, then you hit the cosine button, right? You'll see it on the calculator. And then you hit 30, but then you got to hit equals. Okay, once you hit equals, it'll give you approximately, I should do this. Josh, you're doing it. What'd you get?
I got 1.23. I have 1.234.
You sure? Are you in degrees? Are you in degrees? You got to make sure your calculator is in degrees. There's a thing called radians and degrees, RAD for radians. Sometimes calculators are put in radians. Okay, you got to make sure you're in degrees, DEG. There should be a little mode button or something, I forget. I don't have it in front of me. Now I put a little squiggly equals. Why did I put a little squiggly equals? Because it's what? Approximately equal to. So now somebody put it in there and give it to me. Now if you just have a regular scientific calculator, just a little small one that doesn't graph, this is what you would do. Okay.
6.928.
Yep, you got it. And all you need, they usually ask you to round the sides to 1 decimal place. So Cam, what would that be if you just round it to 1 decimal place?
7.
No, 1 decimal place, not a whole number. 9, right? Because it was what, 6.92 or something? Is that what you said?
Yeah.
Yeah. So the 2 doesn't round the 9 up, so you just make it 6.9. Okay. Put a little squiggly equals. I wouldn't mark wrong if you put an actual equals, but it's an actual squiggly because it's approximately 6.9 because it comes out with a bunch of decimal places after it. So let's go back to the calculator. If you have a regular scientific calculator, this is how I would do it. I would put in 30. Who's got a regular scientific calculator in front of them right now? I got 1, 2. Anybody else? Nobody else? Okay. Put in 30, then hit the cosine. You should have some decimal number, point whatever, point like, I forget what it was, point something. What is it? What's 0.8 something? Yeah, 0.86 or something like that. Okay, and then put times 8 and then hit equals, and then you should still get that 6.9. Everybody see that? So if you have a graphing calculator, you do it just the way it looks right now, 8 cosine 30. If you have a scientific calculator, you got to hit the 30 first, and then you hit cosine, and then you hit times 8 equals, and then you'll still get the same exact thing. You got to practice with this. You got to make sure you know how to use your calculator. And that's what that side is. It's 6.9. That's the length of it. Now, we could solve for y. Let's do that in a different color. We could solve for y. Since we know 2 sides now, 6.9 and 8, we could do Pythagorean Theorem. But I would suggest that you don't do Pythagorean Theorem because this is an approximation. When you put it into Pythagorean Theorem, you're squaring it. So you're squaring an approximation, which makes it even more approximate, I guess, if you want to say it that way. So I don't do that. I'm going to use another trig function. So again, we know the hypotenuse. We know this is 30. We're trying to solve for this. What is this side in relationship to the 30 degrees? It's opposite. So now I've got opposite and I've got hypotenuse. Which one of these trig functions uses opposite and hypotenuse? The sine. That's right. So what do? This is good practice for us. So I take the sine of 30 equals the opposite, which in this case is y, over the hypotenuse, which is 8. Now it's the same exact math, isn't it? Except you're just putting in sine instead of cosine. So let's see how that works. So I multiply both sides by 8. Okay, that cancels out. So y, I'm going to put squiggly, right? Approximately equal to, and then throw that in your calculator. Now, I did not do that in my notes, so I'm going to have to do that on my calculator. I actually have a regular scientific calculator app on my phone. Now, I'm not letting you guys use your phone because I don't basically trust you using your phones on a test or a quiz. So, but if you wanted one at home or something, you can always go to the app, go to Scientific Calculator. It's free, right? It's just a little app you could use. So what I'm going to do is I'm going to put 30, then I'm going to hit sine. That's a half, okay, times 8. I can do that in my head now. What's half of 8? It's 4, all right? So actually, I don't even need approximately, do I? Because the sine of 30 is exactly a half, so I could put a regular equal sign, and that's 4. So y is 4 right there. So those are my sides, my missing sides of my triangle. Yes, sir? Yes. And there you go. All right, we got a little bit more to do and a few more minutes left. So let's do another one. Remember I said eventually they're going to ask you to solve for the triangle? We basically did right here. So they're just going to do it again. And let's do this. Transform, go to this thing, flip vertically, and yeah, that's all I needed to do there. And let's stretch this out. So I'm making this look like example 4. Kind of looks like that. All right, it's a right triangle. They put a lot of letters here. They call this X, Y, and Z. So that's Y, and this is Z. They're capital letters. Angles are always use capital letters, and the sides use lowercase. So this would be little x. This would be, they tell you this is 10, and they tell you this is little z. I'll try to make it little. All right, they tell you this is 35 degrees, this angle right here, and they ask you to solve for the triangle. This is example 4. So they ask you to solve for the triangle. So let's do it. What do we got to solve for? It's basically the same problem as what we did earlier, except it's 35 degrees and this is a 10 instead of an 8. And the triangle's kind of flipped a little bit, right? That's really the only thing different. So what's the easiest thing to do? Before we do any trig, what's the easiest thing to do so far? I would say angle y, wouldn't you? Remember, this is 90. This is 35. So how do we find angle y? It's just 90 minus 35, just like we did on the last one. And what is that, 55? So angle y is equal to 55 degrees. So I know that angle right there. Let's find one of the sides. Doesn't matter which one. We could do x or we could do z. Let's do x, since that comes first in our alphabet. So let's do x. What are we going to use? Well, what do we know, first of all? We know this side. So what is this side, this 10 to this 35 degrees? Is it opposite? Is it adjacent? Is it hypotenuse to that 35 degrees? What is it? This is adjacent. It's next to. This would be opposite, wouldn't it? This one is adjacent. What is the z? Come on, it's the hypotenuse, okay? That's the hypotenuse. This is adjacent. What is the x? What did I say the x was? Opposite. So I've got opposite and I've got adjacent. Which one of my trig functions? I'm not even going to write it down this time. Sohcahtoa. Which one of my trig functions uses opposite and adjacent? Is it so? S-O-H? No, that's got hypotenuse in it. Is it the ka? The C-A-H? Adjacent over hypotenuse? No, that's got a hypotenuse in it. So what is it then? It's tangent, because tangent is what? Opposite over adjacent. So that's the one that I use. That's the thing, what I did right there was the thing that students have the most difficulty with, because they always ask me, I don't know which one to use. I don't know what to use, the sine, the cosine, or the tangent. Okay, well, you look to see what you're solving for. You look to see what they give you, and then that'll tell you which one of your trig functions to use. All right, so I'm going to use the tangent. So I'm going to write the tangent of what? The angle that I'm dealing with. I'm dealing with this 35 right here. So I take the tangent of the angle is equal to opposite over adjacent. Which one is opposite? X. Which one is adjacent? 10. And now I can solve for x. The math is exactly what we did earlier. So it's 10 times the tangent of 35. Oh, I'm going to put a squiggly because I'm going to put it in a calculator because this doesn't come out exactly. So that comes out approximately 7.0. You're like, well, Mr. Hammer, why don't I just put a 7 instead of 7.0? And that's the same thing. Yeah, but if I ask you to round it to one decimal place, I got to have that decimal place. Sometimes it happens to be a 0. So let me put that in my calculator because I just have it in my notes. So the tangent of 35 is like 0.7002, and then I multiply that by 10, and that gives me 7.002, and then blah, blah, blah. But what does that round to? 7002. See, that's rounded to the third place. I want to round it to the first place, so that 0 doesn't make that go up or down, so it just stays 7.0. All right, so that's what x is. Let's solve for z this time. Let's go green. Again, I don't want to use the one that I just found because this is an approximation. So let's stick with the one that they give you and try to find the one that they're looking for, that they ask for, okay? Stick with the 35. So what is this? This is the hypotenuse, isn't it? So what do I have? I got adjacent, I got hypotenuse. Which one of my trig functions, which one of my 3 trig functions uses adjacent and hypotenuse? It's the cosine. That's right. It's the cosine, right? So we use the cosine. So we're going to use the cosine of that same angle, 35 degrees, equals, what is the cos? It's adjacent over hypotenuse. What side is adjacent? 10. What's the hypotenuse? Z. The math on this is a little bit different, all right? So you got to watch. Let's see. Is this my last one? When are we at here? 5 till? Okay, good. So watch very carefully on the math on this. I got to solve for z, but this time z is not on the top. My variable is not on the top. It's on the bottom. So I can't just multiply by a 10 or divide by a 10 because z is still on the bottom. So watch what I'm going to do. Everybody watching? So what I'm going to do is I'm going to multiply. Oops, there goes my thing again. Happens every day, doesn't it? Okay, I'm going to multiply by a z, so that cancels out here. Where does it go over here then if I multiply by a z? It goes on top there. Everybody see that? Now, I got z on the top. I got to get rid of that cosine of 35. Remember, the cosine of 35 is just a number, just like any old number. It's a decimal, but it's a number. How do I get rid of the cosine of 35? It's being multiplied. How do I get rid of something that's being multiplied? I divide. So watch what I do. I'm going to divide this by the cosine of 35, and I got to take the 10 and divide that by the cosine of 35. It gets a little messy. I'm just going to write it out. So z equals 10 divided by the cosine of 35. And that's what you're going to have to put in your calculator right there. So it's a little different. So when your variable is on the bottom, you're actually going to do a division, right? So I take the z, put it on the left-hand side, take the cosine of 35, put it on the right-hand side, but it goes on the bottom because I'm dividing. So it's 10 divided by the cosine of 35. So if you do that, you get approximately 12.2 if you round it to the first decimal place. You're going to have to practice that. That's the hardest one out of all the little algebra things that you have to do. That's the hardest one. But once you get it down, it's really not that bad. But practice it. You got to practice. Practice this on your calculator. If you have a graphing calculator, you just put 10 divided by cosine 35 equals, bam, there's your answer. So it's nice that way. if you have a little scientific calculator without the graphing, this is what I would do. I would put 10 divided by, and then I put 35 cosine, hit equals, and then you should get 12.2. You have to practice it. Make sure that you know how to put the stuff in the calculator. Everybody thinks, oh, I got a calculator. I should be able to do great on this test because I'm using a calculator. Well, you got to know how to use it. Okay, and sometimes using the calculator is just as difficult as doing the math to get to this point. So make sure that you put this in your calculator and you get a 12.2. We got one more to do. Example 5. Oh. What color haven't we used? Can you see this purple? Oh, can you see that? Yeah, that's pretty good. So this is example, what is it? 5. And we'll be done with this one. All right, let's put a triangle here again. I know today's lesson is a little bit long, but, you know, got a lot to learn. This is A, this is B, this is C, this is 5, this is 12, and this is 13. This is another one of our special triangles. Remember the 3, 4, 5? This is another special one, 5, 12, 13. I'm not going to go through that right now. Now look, they give you all 3 sides, so what do you think they're going to ask you to find? They're going to ask you to find both of these angles. So watch carefully. I've only got a couple minutes, so I'm going to go fast. We'll redo this. I'll give you a worksheet today to work on for homework, but tomorrow we'll go over it a little bit. But I got to go through this quick because I only got a couple minutes left. So this is what we do. I'm trying to solve for A this time. I don't know what it is. I don't know it's 30. I don't know it's 35. I don't know what it is. That's what I'm trying to find. So that makes this a lot different than what we did before. But look, I've got all 3 sides. I can use any trig function that I want. Okay, what's your favorite trig function? Anybody got a favorite? Tangent? Okay, let's use the tangent. So let's say the tangent of angle A. I don't know what angle A is. That's why I'm going to put an A right there. Is equal to, what's the tangent? Opposite over adjacent. Which one is opposite of angle A here? 5. Which one is adjacent to angle A? The 12. Okay, now you're looking at this. Now I'm going to do something here. It might freak you out a little bit. So I want to get A by itself. So I have to get rid of the tangent. A lot of people think you would divide by a tangent. But can you divide by a tangent? No, because remember, tangent's not a variable. It's not a number. But what I can do is take the inverse of the tangent. Now, don't freak out. Just watch, okay? So what I'm going to do is I'm going to write the inverse. Watch. It'll cancel out. But I got to take the inverse tangent of this side. I'm going to take the inverse tangent of this side. Now, watch what it looks like. It looks like this. It looks tangent to the negative first. That's how we represent an inverse tangent. You'll see that on your calculator. Look on your calculator. Look at tangent. Do you see on the screen itself? It's probably a different color. It's got tan to the negative first. Yeah, that's what that is. And so here is how we do this. Now watch. Don't leave. I didn't dismiss you. This is what we do. We hit 5 over 12. If you have a regular calculator, you put 5 divided by 12, then you hit the second function, tangent. That's how you get to the second, the ones that are written on the screen and not the buttons. So you get 5 over 12, then you hit second function, tangent, and you get approximately 23 degrees. And that is this right here. Okay? Let me give you a worksheet before you go, and then and that'll be it.